So we're going to be looking at different types of studies that we use to collect data, and then how we analyze that data and ways that we can bias or skew the conclusions about a data set. When we read the newspaper or we're watching ads on television, we often hear statements that say things like, survey results show that 47% of Americans believe that blah, blah, blah. And so part of what we have to ask ourselves is, who's collecting the data? How are they collecting the data? What tests are they using to analyze the data and make a statement about a group? So that's the whole point of statistics. It allows us to make conclusions about an entire group of people without actually working with the entire group. It's really hard to talk to every single American in the United States. So when they say things like show that 47% of Americans believe, what they're really probably saying is 47% of the people we actually talked to said this, and if we collected the data in a valid way, we can make this statement about all Americans. Sometimes the results make sense, and sometimes you just kind of look at them and say, that doesn't really seem very reasonable to me. We can make judgments about the validity of a statistical study based on the method of data collection. So what is it, again, that they did to get the data and start to make statements about the data? So when data is collected from the entire group that we're interested in, we refer to that as the population. When members of the group are selected to represent a group through data collection, that is a sample. So population is everybody, sample is a small group. And then the item that the researcher is collecting data on is the parameter of interest. So what is it we're looking at? Are we looking at how they feel about how the President of the United States is performing? Are we looking at how they feel about medication, if they're taking a certain medication? Anything like that is a parameter of interest. So 3 different areas that you've looked at before. We can complete a survey. So we collect information about the parameter of interest by asking questions. So we're not really controlling anything. We're just kind of asking somebody's opinion. So if you get a receipt at the store and it has you complete a survey, there's asking you about your shopping experience and customer service and all of those types of things. Observational study. The researcher observes behavior of participants to collect data without influence. I don't have any control over anything. This is already happening, and so I'm just looking at it and seeing what's going on without controlling anything. Versus an experiment, the researcher manipulates the variables to determine cause and effect. So this is things like if a researcher is going to test a medication, one group of people is going to take the medication, the other group is not going to take the medication, or they're going to take a placebo drug, and then we compare how those 2 groups, the results of whatever the medication is supposed to fix. So advantages for the survey, it's much more cost effective. It's easier for data collection. Typically it's anonymous, which means people are more willing to answer questions honestly and be a little more forthcoming, right? Disadvantages, sometimes if the questions aren't worded correctly, the researchers can make some assumptions. The other thing is that oftentimes it's kind of like a multiple choice question, and so somebody may be in between 2 opinions but not really be able to voice that, or maybe their actual opinion isn't displayed on the survey, and so they would have to answer in a way that's not 100% how they actually feel. Advantages for an observational study. It gives us information about real situations. We're not influencing the environment. So we're seeing actual information and data that's realistic. However, we can only claim association, meaning we don't really know if there's lurking variables or other things going on that can affect the outcomes. It's very time consuming because you're not controlling, so sometimes it's just sitting around and waiting to see if the situation is going to be there so that we can actually collect data. You also may not have a true sample, so a sample should be a realistic representation of your population, meaning everybody in the population should have had the same likelihood of being selected to be in the sample. But with an observational study, if you're gonna find, research something about exercise tendencies, it may be harder to find people that don't exercise because they're probably sitting at home on their couch versus being at the gym where you might go to talk to people that actually exercise. An experiment, the advantage, you have a little bit more control. It's easy to replicate, meaning we can conduct the same experiment multiple times to compare outcomes. It's cheaper and less time consuming because sometimes with observational studies you have to travel more to go to the places where the event is occurring that you're trying to observe, versus if it's an experiment, I can recreate that wherever I'm at without having to travel to a certain group of people. But that also means that it's an artificial environment. We kind of are controlling things so much that we don't really know if this is what would happen if we weren't asking people to take the medication every day, if they were having to do that on their own. And it's still difficult to generalize, meaning we can make conclusions about the people that actually took or participated in the experiment, but it's hard to generalize that to the population at large. So we talked a little bit about, in order for our statistical data to be representative of the larger population, the individuals in the sample have to be chosen at random, meaning everybody in the population has an equal chance to be selected as every other person in the population. So thinking about if you're watching a certain news channel and they've completed a survey and then they tell you that a certain percentage of the population feels this way, well, did they really get a true sample of the population, or did they just get a sample of the people that actually watch their news station? And so that's what goes into this idea of being biased. Bias is a tendency to over or underestimate the value of the interest parameter from systemic favoritism. So the two types of bias that we're going to focus on is selection bias. And so we talked a little bit about that means that proper randomization is not achieved, right? If I only talk to people that watch my news station, that's biased because I may not be getting an accurate representation of somebody that doesn't have the same views that I do, because we tend to gravitate towards the people and the things that represent the same way that we think or the same way that we feel. And then information bias is that the data that's actually measured or collected or analyzed, none of that is done correctly. Just meaning that somebody made a mistake, somebody didn't really think about or conduct the proper tests, or they didn't make the right statement at the end. So a couple of examples. You survey customers at a mall. You want to know which stores they shop at most. Which sample is more likely to be random? You survey shoppers in a computer store, or you walk around the mall and survey shoppers. Answer choice B is going to be more random because the people in A obviously like computers. Me personally, I'm not going into a computer store. I'm going to go and check out shoes and makeup and clothes. So to get a true random sample, we have to make sure we're involving everybody. Question 2. You survey a store's customers. You ask why they chose the store. Which sample is more likely to be random? You survey 20 people at the entrance from 5 p.m. to 8 p.m. Or B, you survey 20 people at the entrance throughout the day. If you said answer choice B, then you are correct. From 5 to 8, who's not going to be at the store from 5 to 8? Senior citizens, because they're probably out early in the morning. People with small children are probably at home or taking them to events that they have to to do. People that just got off work are going to be the people that are more likely to be there 5 to 8 because they're probably trying to run some errands before they go home. So if we limit it to that time frame, we're not getting a representation of everybody that we possibly could. So for 3, is each question biased or fair? Part A, do you think that soothing classical music is more pleasing than the loud, obnoxious pop music that teenagers listen to? That question is definitely biased. When they use descriptors such as soothing or loud and obnoxious, we are not asking a fair question. So this is an example of bias, that informational bias that we talked about. So question B, what do you think is the most common age group of people who like pop music? That's a fair question, even though I think if you were writing a survey, you may want to actually list out the age ranges. So again, when we talked about that, survey questions tend to be a little bit more rigid. So if we actually gave them the age ranges to choose from, it may be a better question. But for the most part, I think it's fair. I don't think it's leading towards anything. Question C, do you prefer classical music or pop music? So I think that this would be a fair question, even though there's a problem with the question in that you're not leaving them the choice to say neither. Maybe I don't listen to either of those. Maybe I listen to rock music. Maybe I listen to heavy metal. There's got to be some other choices there. All right, so this should be another set of questions. So, do you prefer greasy meat or healthy vegetables on your pizza? Is definitely the biased question because they're, again, using those descriptor words. Greasy meat, I don't really care if it's greasy. I still want pepperoni on my pizza. I know that vegetables are healthy for me, but if I'm eating pizza, does it really matter if there's healthy vegetables on the pizza? Probably not. Question F, which pizza toppings do you like best? Is definitely a fair question. Again, when you're writing survey questions, you want to make sure that you're giving some selection. It makes it easier to test the data. So which pizza toppings do you like best? We might want to give them some ways to choose and select those. So again, lots of different ways to interpret data. Part of our job as we learn about statistics is just being able to ask the question about how did you come to that conclusion, and is it really a fair conclusion? Is it an accurate representation of what you're trying to tell me is actually happening?